Good evening. In this session, I am going to explain you JEE Main Phase 2 2nd April question paper, morning shift physics question paper. In the previous session, actually I explained problems from 26 to 41. We will continue with question number 42. See here, read the question carefully. This is question number 42. A spherical surface separates two media of refractive indices 1 and 1.5. So, this is the spherical surface separating two media of refractive indices 1 and 1.5. In the question it is given an object is placed at a distance 0.2 meters here and the radius of curvature of this curved surface is given as 0.4 meters. Okay, find the image distance, that is all. So, we know straight away the formula is mu1 by considering the refraction at a curved surface. The formula we know is mu1 by minus u plus mu2 by v is equal to mu2 minus mu1 by r. In this, the most important thing is sign convention. All the distances measured in the direction of light ray are taken as positive and distances measured in a direction opposite to the light ray are taken as negative. So, here object is placed here. So, this will be the direction of light ray, but the object distance is measured in this direction. So, u has to be taken as negative, then it becomes 1 by minus of minus u becomes plus u plus mu2. Mu2 is given as 1.5, 1.5 by v. This is mu2 minus mu1 by r is given as 0.4. So, here from this 1.5 by v is equal to 1.5 minus 1 is 0.5 by 0.4 minus you have to take this to the other direction 1 by 0.2. So, this is 5 by 4 is 1.25. 1 by 0.2 is 5. So, 1.5 by v, 1.5 by v, 1.25 minus 5 is minus 3.75, from which v is equal to 1.5 by 3.75, right. So, here this gets cancelled 2.5 times 1 by 2.5 is 0.4. So, this is the answer. V is at a distance 0.4 meters. Negative sign indicates image distance is measured in a direction opposite to the light ray. That is, image is also in the same direction at a distance 0.4 meters from the spherical surface. So, correct answer is 0.4 meters left to the spherical surface is the right option for the problem. Problem is straight question, but we have to be cautious regarding the sign convention, right. Let us go to the next problem. See here 43. You have to match the list. Look here. A is coefficient of viscosity. Its dimensional formula is force per unit area, unit velocity gradient. For force, dimensional formula is ml t power minus 2 by area is L square, velocity is L t power minus 1, gradient by distance. So, this becomes, this is m L to the power of minus 1, t to the power of minus 1. So, for A, correct option is m L to the power of minus 1, t to the power of minus 1, it is 4. So, here and coming to the next one, and the second quantity given is intensity of the wave. Intensity of the wave is energy per unit area per unit time. Energy is ml square T power minus 2. Area is L square T. So this and this gets cancelled. It becomes m. There is no L term. L power 0 T power minus 3. If you look at side 3, this is m L power 0 T power minus 3. So the first one. For B, first one. And coming to C. C is pressure gradient. Pressure gradient is delta P by delta X. Pressure is m L power minus 1 T power minus 2 by L. This is m L to the power of minus 2 T to the power of minus 2. So this is m L power minus 2 T power minus 2, that is C. For C, it is 2. So 2. And D. D is compressibility. Compressibility is 1 by bulk modulus. Reciprocal of bulk modulus is called compressibility. So this is compressibility is m L power minus 1 T power minus 2. 1 by m L power minus 1 T power minus 2 is m to the power of minus 1 L T square. So m to the power of minus 1 L T square is 3. So for D, it is 3. So let us look at the options given. If you go to the options given here, look. Look at the second option, A 4, B 1, C 2 and D 3. So option 2 is the correct answer for that problem. So you must know how to write the dimensional formula. Here actually when you are writing the examination, you must have some strategy. After finding out these two, answers are known. For A4, for B1, there is only one option. So actually in the examination, you need not find these two. Okay. Now let us move on to the next problem. Look here. A small bulb of mass 44th question, it is like this. A small bulb of mass 100 milligrams is suspended by means of a string. It is placed by the side of a uniformly charged sheet of surface charge density sigma. When this is given a positive charge Q, that is equal to 10 microcoulombs, this is displaced through an angle 45 degrees and the value of G is given as 10 meter per second square. You are asked to find out the surface charge density of the sheet. What is the concept there? I think you remember tangent law. So when the bob of the simple pendulum is pulled aside through an angle theta, then the horizontal force required to pull it aside through an angle theta is F is equal to mg tan theta. So the necessary force is created by the electric field intensity created by the charged sheet, then force on a charge Q in a field of intensity E is QE. So QE is equal to mg tan theta. Actually, you have to come straight away to that. QE is equal to mg tan theta, where E is equal to sigma by 2 epsilon naught. Electric field intensity due to a uniformly charged sheet is given by sigma by 2 epsilon naught. So substituting that here, sigma by 2 epsilon naught in the question is given as 8.85 into 10 power minus 12, that is equal to sigma by 2 epsilon naught into charge QE. This is E, Q is 10 microcoulombs. 10 into 10 to the power of minus 6. that is 10 power minus 5. So, sigma by 2 epsilon naught is E QE. Q is 10 microcoulomb. If you convert that into coulombs, it becomes 10 to the power of minus 5. M is 100 milligrams. 1 milligram is 10 power minus 6 kg and G is given as 10. Tan 45 is equal to 1. So, let us 1, 2, 3, this becomes 10 to the power of minus 3. So, this gets cancelled 10 to the power of minus 7 times. Sigma is equal to 10 to the power of minus 3. If you take this to the other side, 2 into 8.85 is 17.7. 17.7 into 10 to the power of minus 7. So, this is 17.7 into 10 power minus 10 or sigma is equal to 1.77 10 to the power of minus 9. Okay? And charge density means coulomb per meter, surface charge density means coulomb per meter square, but 10 power minus 9 is nanocoulomb. So, 1.77 nanocoulomb per meter square is the surface charge density. So, the correct option is fourth option, 1.77 nanocoulomb per meter square. Now, let us go to question number 45. See here, in question number 45, a monochromatic light incidents on a metallic plate with work function phi. An electron emitted normally to the plate from the point with a maximum Ke enters into a constant field perpendicular to the initial velocity of the electron. Electron passes through a curve and hits back the plate at a point B. Distance between A and B is asked. So, here look here, electron enters into a magnetic field, electron passes through a curve and hits back the plate at a point P. See here. So, first of all, this is the plate, photoelectric plate. An electron is emitted and immediately after getting emitted from the plate, electron enters into a magnetic field applied at right angles. When a charge enters into a magnetic field at right angles, its path is circle. So, it takes a circular path. So, here this is the point A at which the electron is emitted. This is point B at which the electron hits back the photoelectric plate or that photometal surface. So, here this distance is asked, that is nothing but 2r. When a charge enters into a magnetic field at right angles, the magnetic force provides the necessary centripetal force. So, BQV is equal to mv square by r, from which BQV is equal to BQV and gets cancelled. So, you will be getting BQ is equal to mv by r, or that is P by r. And we know from the relation Ke is P square by 2m, BQ is equal to square root of 2m Ke by r. So, if you are thorough with the formulae, by just reading at the problem, you have to arrive at that relation. Okay? So, BQ is equal to square root of 2m Ke by r. Again, let us go back to the concept. Here, 2r is asked. So, the formula for r becomes square root of 2m Ke by B. Q is charge of the electron, because here electron is given, so electron charge. Now, what is this kinetic energy? Kinetic energy is the kinetic energy of emitted photoelectron. From Einstein's equation, what do we know? H here, monochromatic light is incident on a metal plate having work function. So, and this is H nu, that is equal to kinetic energy plus work function. So, kinetic energy is equal to H nu minus phi or Hc by lambda minus phi, and just you need to substitute that over there. So, here you have to see the options and decide the answer. So, here it is kinetic energy is replaced by this expression. We want 2r here, r expression. So, 2r becomes 2 times square root of 2m. Kinetic energy is Hc by lambda minus phi divided by Be. This is the answer. So, if you look at the options, this 2 is taken inside. So, when it is taken inside, the square root 2 becomes 2 square. So, altogether the distance between A and B is square root of 8m Hc by lambda minus phi divided by Be. So, this is the correct option. 3 is the correct option for that problem. I am telling you the concept here, it is very simple. So, a photoelectron emitted with its maximum Ke entered into a magnetic field at right angles immediately after emission. Again it strikes the plate at another point. You have to find the distance between the point of emission and the point where it strikes back the metal. So, that distance is nothing but the diameter of the circular path. And here when a charge enters into a magnetic field, BQV is equal to mv square by r, from which BQ is mv by r, P by r, or BQ is equal to square root of 2m Ke by r. You have to be absolutely thorough till then. So, directly you can take that. BQ is square root of 2m Ke by r, from which r is this much. Now, we want to find the value of Ke in terms of the data given. From Einstein's photoelectric equation, energy of incident photon is maximum Ke possible for the photoelectron plus work function, from which Ke is h nu minus phi or. So, just we substituted that value over there and we could get the 2r, that is the distance between the point of emergence and point where it strikes the photometal again. Okay, that is an interesting question and easy. Now, go to the next problem. Look here, 47th one. A steel wire of length 2 meters, see here, steel wire of length 2 meters, Young's modulus is given as 2 into 10 to the power of 11 Newton per meter square is stretched by a force. Poisson's ratio is given as 0.2 and transverse strain is given as 10 to the power of minus 3 respectively. What is the elastic potential energy stored? It is given, it is numerical questions. So, something into 10 to the power of 5 in SI units, you have to find this. See here, elastic energy expression is U is equal to half stress, here potential energy density, energy per unit volume, that is half stress into strain, or this is half strain square into Y, because stress by strain is equal to Y. So, if you want to eliminate stress, stress is equal to strain into Y. So, it becomes strain square Y. If you want to eliminate strain, half stress square by Y. But here the data given is this formula we are going to use as per the data given. Look here, sigma is equal to lateral stress divided by longitudinal stress, lateral strain divided by longitudinal strain. So, here in this formula we are using longitudinal strain. So, that strain is equal to lateral strain or transverse strain, that is 10 to the power of minus 3. From this longitudinal strain will be lateral strain or transverse strain divided by Poisson's ratio. Poisson's ratio is given as 0.2. So, here strain is equal to 1 by 0.2 is 5 into 10 to the power of minus 3. Then the problem is done. So, energy substituting in this expression, half strain square, 5 square is 25 into 10 power minus 6 and y 2 into 10 to the power of 11. So, here 10 to the power of minus 6, 10 power 11, 10 to the power of 5. 2 and 2 gets cancelled. We are left with 25. So, the value here is 25. So, the problem is half strain square into y. There that strain is longitudinal strain. So, here Poisson's ratio is given, transverse strain is given. So, Poisson's ratio is lateral strain by longitudinal strain. From that we could get the longitudinal strain and substituted that for value here, and finally we could arrive at energy density. Next problem, 49th question. Look into this 49th question. Look here. 48th, we need to complete this 48th question also. So, look into this 48th. The measured angular separation between second minimum and to the left of the central maximum and third minimum to the right of the central maximum. Third minimum to the, this is to the left of central maximum and this is right of central maximum. Angular separation between them is given as 30 degrees. In a single slit diffraction pattern using a source of wavelength 628 nanometers. Find the width of the slit. That is the question. Actually, single slit diffraction means A sin theta is equal to n lambda for the nth dark fringe from the central fringe. So, here second minimum is A. When theta is considered as small, A theta is equal to second 2 lambda, right. So, theta is equal to, or theta 1 is equal to 2 lambda by A. Similarly, third minimum on the right. Suppose if this is the central one, this is first minimum to the left, second minimum to the left, this is the first minimum to the right, second minimum to the right, third minimum to the right. So, this distance becomes, look here, A theta 2 is equal to third minimum 3 lambda by A from which theta 2 is theta 2 is equal to 3 lambda by A. So, 3 lambda by A. So, theta 1 plus theta 2 is equal to 2 plus 3, 5 lambda by A. Theta 1 plus theta 2, the angular separation between these two is given as 30 degrees. 5 lambda by A. Now look here. So pi by 3 is equal to 5 lambda 628 nanometers, 10 power minus 9 divided by A. Pi is 3.14. This is 200 times. So A is equal to 3 into 5, 200, 10 power minus 9. 5 200s, it is 1000. 1000 into 10 to the power of minus 9. So here it is just let me check it back. So pi by 30 degrees. This is not pi by 3. 30 degrees is equal to pi by 6. So this is pi by 6. So this is also pi by 6. Okay. So this becomes 6. So this is 6 into 10 to the power of 9 or 6 micrometers. That is the width of the slit. I will tell you once again. But in this problem, definitely we have taken an approximation. Otherwise, the problem is becoming too lengthy. Theta 1, sin theta 1, the other one becomes sine of 90 minus theta 1 and so on. Sine of 60 minus theta 1. So the problem is becoming so lengthy. So here coming back, it is given that with respect to the, look here, if the measured angular separation between the second minimum to the left of central maximum, this is central maximum, to the left second minimum, to the right third minimum are separated by 30 degrees. Angular separation between them is given as 30 degrees. So here A sin theta is n lambda in single slit diffraction. When theta is small, sin theta is taken as theta. So in the first case, A into theta 1 is 2 lambda, from which theta 1 is 2 lambda by A. Similarly, theta 2 is 3 lambda by A. Theta 1 plus theta 2 is 5 lambda by A. That's it. So here theta 1 plus theta 2 is given as 60 degrees, that is pi by 6. So pi by 6 is equal to 5 lambda 628 into nano 10 power minus 9 divided by A. That's it. On simplification, you got A as 6 micrometers. Okay. Okay. Next, let us go to question number 49. Read the problem carefully. Question number 49. Here, gamma A is the specific heat ratio of monoatomic gas having 3 translational degrees of freedom. Based on degrees of freedom, gamma ratio of specific heats is 1 plus 2 by F. It has 3 degrees of freedom, 2 by 3. So if you take LCM, 3 plus 2. So gamma of the first gas is given as 5 by 3, right? And look at the continuation. Another gas having gamma B is the specific heat ratio of polyatomic gas having 3 translational degrees of freedom, 3 rotational degrees of freedom. So degrees of freedom, 3 translational, 2 rotational in case of the second gas, and 1 vibrational mode. That is the most important point of the problem. Each vibrational mode is associated with 2 degrees of freedom. one because of its kinetic energy and the other because of potential energy. So, one vibrational mode indicates it has 2 degrees of freedom. So, altogether in the polyatomic gas given, total degrees of freedom is 3 plus 2 plus 2, 7. 3 plus, just 1 second. So, here it is mentioned that, look here, 3 rotational degrees of freedom, 3 translational degrees of freedom and 1 vibrational degree of freedom. So, each vibration is associated with 2 degrees of freedom. One is because of its potential energy and the another is because of its kinetic energy. So, altogether degrees of freedom in the second case is 8. So, gamma B is equal to 1 plus 2 by F, that is 8, 8 plus 2, 10 by 8, that is equal to 5 by 4, that is gamma B. You are asked to find gamma A by gamma B. It is equal to 4 by 3. So, answer is 4 by 3. Here it is a numerical question. It is given that gamma A by gamma B is 1 plus 1 by n, that is equal to 4 by 3. 1 by n, 4 by 3 minus 1, it is 1 by 3, which implies n is equal to 3. So, if it is 1 plus 1 by n, then find the value of n. So, answer is 3 here. Okay. Now, let us go to the last question, question number 50. Again, this is last question is from the first topic, that is kinematics. So, look here, a person travelling on a straight line moves with uniform velocity v1 for a distance x and with a velocity v2 for a distance 3x by 2. Average velocity is 50 by 7 meter per second and V1 is also given a 5 meter per second. Find V2, that is the question. So, it is so simple. Average velocity is equal to total displacement by total time, that is S1 plus S2 by time, S1 by V1 plus S2 by V2. Here total displacement x plus 3x by 2, x by V1 is 5 plus S2 is 3x by 2 and V2 we need to find it out. This is given as 50 by 7. So, you can take that x as common and you can cancel it. Then 50 by 7, 1 plus 3 by 2 is 5 by 2. 5 by 2, 1 by 5 plus 3 by V2. So, we need to find out V2. So, if you apply cross multiplication, 1 by 5 plus 3 by V2, just we are taking this to the other side. It is equal to 5 by 2 into 7 by 50. So, gets cancelled 10 times. So, 3 by V2 is equal to 7 by 20 minus 1 by 5. So, this is 20 times. So, 7 minus 4, that is 3 by 20, from which V2, 3 by 2 V2, 2V2 is equal to 20. Look here, from this 3 by 2V2 is equal to 3 by 20. 3 and 3 gets cancelled. 2V2 is 20, implies V2 is equal to 10 meter per second. So, that's all about the JEE question paper explanation. If you genuinely look at the question paper is not at all difficult. So, only thing is you have to concentrate on the paper, and you should never be distracted while answering the question paper. Okay, I'll stop here with this explanation. I'll come back to you with the explanation of another paper given in JEE Main 2025. Thank you and bye-bye.